Hello, guys. Welcome back to Knowledge Bites of CS. Today, we will continue with what we did last time. As I mentioned last time, for CS topic 2, there are two parts: computer architecture, the RAM, the ROM, the primary memory, secondary memory, and the MAR, MDR, CU, ALU. All that stuff is computer architecture, the first part. Now, the second part of topic 2 is about digital logic. So, we will do digital logic today. Uh, Now, let's go. The first word for digital logic is OS, or an operating system. This is the hierarchy. You have the user, yourself, then the user is interacting with an application. Right now, I am recording it on the Google. So the application is Google, and underneath the application, you have the operating system or the OS. And then underneath the operating system, you have the physical hardware, which you're using: the laptop, the webcam, the microphone, stuff like that. So the OS is a system software that manages a computer's hardware and software resources and provides common services for computer programs. These words highlighted in blue are important: computer hardware and the software that provides the services for computer programs. Basically, that's what an OS is. Five functions of an OS, operating system. This is important. What usually questions come like, what are the functions of the OS, or give three functions of the operating system. So these are the functions: A, B, C, D, and E. We shall take each function and go into it a little further. The first one: operating system provides a user interface. OS has a link between the user and the computer hardware. The link is called the user interface. Now, in the user interface, there are four types of user interface: graphical, command line, natural language, and menu based. Graphical user interface is what we see: the icons and the menus and stuff like that. Command line interface, where the user types in the code. We can say it's like the command prompt or the Windows PowerShell, stuff like that is the command line interface. Natural language interface, where the user speaks to the interface. And menu based interface, where the user is given a selection of options and you can select which one you want, kind of like a drop down option, if you would, like that. That's menu based interface. Second function of the operating system is memory management. Is done by keeping track of the storage devices like the hard disk drive, and controlling which application has access to the primary memory or RAM. As I said last time, usually when we say memory, we mean RAM, or random access memory, because this is the memory we can access, we can read, write. ROM, we cannot do anything, but RAM, it's the one which we access. So anything, suppose I create a document, the document is stored in RAM, it's not stored in ROM. Anything I do, suppose I load up Skype is in RAM. Uh, that's what I'm Memory is RAM, basically. Each location in memory can be read, modified, and written by the OS. When a memory location is full, the OS sends a confirmation message. Similarly, the OS provides file management services by sorting out where the data is stored on the disk, drivers, and memory. And the OS allows users to organize files in folders as well as to copy and delete files, like Control C, Control V. Suppose I move a file from one place to another. It is still in RAM, but in a different place in RAM, where the memory address register, the MAR changes, the address of the file changes, but it's still there on the RAM. C, it does peripheral management. Peripheral management is anything you plug in or connect to the device. Suppose we can plug in the keyboard, we plug in the mouse, we have monitors, we have printers. They are controlled through device drivers. A device driver is a software program which allows the hardware device to be used by the OS. They act as translators between the devices and the computer systems. Peripheral management, we can say, is anything basically not in the computer. Yes, we can say like that. Anything not in the computer is peripheral, so it manages everything which is not in the computer. You have, suppose you have the physical plug-in printers, but nowadays printers come with Wi-Fi also, and then you can download the device drivers through the internet. The OS function also allows multitasking. It coordinates the working of different programs and allocating the CPU time between different programs based on the time and priority of the software application. Right now, suppose I'm using Chrome. So Chrome right now has the most time and priority. Suppose I have another application in the back running. Suppose Skype is running in the back, but right now I'm not using Skype, but I'm using Chrome right now. So the system will put more resources to Chrome than Skype, because Skype is now just in the background. Chrome is in the foreground. I'm using Chrome. I'm actively interacting with Chrome. Uh, and suppose now two things I'm doing. I have the screen recorder and Chrome. So the OS manages time between both of them. Yeah, each task is given a slice of time on the turn of the CPU, and each task has to wait for its turn unless it's given a higher priority by the OS. Suppose I close Chrome right now and open Skype. Skype now, because Chrome is closed, so Chrome is given a lesser priority, and Skype is given a higher priority because I'm now using Skype. So Skype right now will have higher priority. So for multitasking, the OS coordinates the working of different programs by allocating CPU time. It bases its decision when to allocate what time based on the time and priority of the software application. Suppose I close one application, open another application. The application which I opened now will be given a higher priority by the operating system because I'm using it now. And the one I just closed, its priority will be lessened. Security. The OS prevents unauthorized access. It ensures security of the system through username and password, and the OS protects files from other users reading or writing files. Like suppose the Word document, you can have the password protected Word document, and usually if you have set it up, once you start your system, you'll have to give a username and password. So that is managed by the OS. It's security. Yeah. So that's what the OS does. Security, multitasking, peripheral management, memory management, and user interface. These are the functions of the OS. Now, common application software is word processor, not word processor. Also, there is spreadsheets, not Excel, but spreadsheets. There is also database management system, email client, not Gmail, email client, web browser. We can say that Chrome is a web browser, computer aided design, and graphical processing software. Word processor is a program for storing, manipulating, or formatting text entrance from a keyboard and providing a printout. So it's not Word, but a program for storing, manipulating, or formatting text. Spreadsheet, same. It's a program in which data is arranged in rows and columns in a grid-like pattern, which can be manipulated and used in calculations. So not only Excel, anything where the data is arranged in rows and columns and can be manipulated and used in calculations. A database management system is a software system for creating and managing database. It provides users and programmers with a systematic way to create, retrieve, update, and manage data. Email client, a computer program used to access and manage users' email, not only Gmail. Gmail is one email client, but it's not everything. A web browser is a software application for retrieving, presenting, and transferring information resources on the World Wide Web, the www.com. That's the World Wide Web. This is the most downloaded browsers of 2017. We can say that Chrome is way ahead of the pack with 74%, and Safari is with 14%. Then we can see Edge, Firefox, and Opera. Computer aided design program that user computer system to assist in the creation, modification, analysis, or optimization of a design. Basically, CAD, anything that can basically be used to optimize a design or assist in the creation of it. Graphic processing software, basically where you can edit an image or like collection of programs that enable a person to manipulate visual images on a computer. Basically, it's graphic processing software is anything relating to editing of images. CAD is anything relating to the assisting in the process of designing something. Web browser, anything that helps to retrieve, present, or transfer information from the World Wide Web or www. Word processor is anything for storing, manipulating, and formatting of text. Spreadsheet is a way in which data can be presented in rows and columns and can be used in calculations. A database where the user and program with a systematic way to create, retrieve, update, or manage data. And an email client is where the user can access their email. Common features of an application, there are toolbars, menus, dialog boxes, and GUI components. GUI components is graphical user interface, as we discussed over here. Yeah, over here, GUI, graphical user interface, that have menus and icons. Basically anything which you can see, which the user can interact with, that is a GUI component, graphical user interface. Some are OS generic, operating system generic, like file, edit, view, this one. Some are program specific, like this is in a Word. We can see that this is program specific, the red line, but this first toolbar is OS generic. So that means any software on the operating system, it will look like that. This is what it is. OS vs application features. Certain parts of the interface are provided by libraries in the OS, and certain parts are specific to each application. The menu bar and buttons are standard, but the specific pictures are up to the individual application. So this is an example where what is OS generic and program specific. This is for the Word. Now, now a computer can understand in something called binary, which is 0 and 1. So now this is the basically the representation of data. Right now we're dealing with the representation of data. So the most fundamental way to represent data is a bit, where, as I said, computers use binary, the digits 0 and 1 to store data. A binary digit or bit is the smallest unit of data in computing. It is represented by a 0 or a 1. So the computer cannot understand human language. Anytime you type something, suppose A, it gets transferred to a language which the computer can understand. And what language the computer understands? Binary. Binary is a basically representation of human language in forms of 0 and 1. The 0 and 1 can be uh, also interpreted as on and off, true or false, yes or no, depending on the situation. Now, what is a byte? A bit is a representation of a base 2, a 0 or 1. A byte can be grouped together to make them easier to work with. A group of 8 bits is called a byte. So 8 zeros and ones are called a byte. Now binary, computer uses binary, the digits 0 and 1 to store data. It has two symbols, 0 and 1. So it is a base 2 numbering system. It also refers to the format in which numbers are transmitted and calculated in a computer system. Now, denary or decimal. Decimal is what we humans use. Denary is a numbering system with 10 symbols: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It is therefore often referred to as a base 10 numbering systems. This one is binary, is a base 2 numbering system because there are two possible inputs or outputs, 0 and 1. Denary or decimal is a base 10 numbering system because it has 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. 0 is also counted as a symbol. Over here also, for binary also, 0 is a symbol. Now, what is hexadecimal? So this is binary or base of 2 numbering system where 0 and 1 is there. This is decimal where it is as a base of 10. So 10 numbers are there. Now what is hexadecimal? Hexadecimal is a base same as base 10 but with symbols also. Hexadecimal is a numbering system with base 16. 16. So 16 base. So there will be 16 symbols, 0 to 9, and then we have A, B, C, D, and F. So there is a total of 16 symbols. In binary there is 2, in decimal there is 10, and hexadecimal there is 16. What is the use of hex? Hex or hexadecimal? Hex is often called, is used to represent very large numbers quickly, such as those used for color representation. This is an example of hex color representation. Usually when we represent colors in the computer, it is in hex only. So the use of hex is to represent very large numbers quickly. So we can say that this is 0 as 0, 9 as 9. We can say A over here as the 10th symbol in the 16 numbering system. So B is the 11th, C is the 12th, D is the 13th, E is the 14th, F is the 15th, and then 0 is also a symbol. So we can say that binary has a base 2, 0 and 1. Decimal has a base 10, 0 to 9. Hexadecimal has a base 16, 0 to 9 from the decimal, and A to F in the alphabets. Like we can see, suppose we take white for example, it's all F's, and black for example is all zeros. we can see that everyone has some combination of numbers or letters. Suppose we can take some from the pink. We can see that FF0099. Suppose that's there. And also we can take another one from the pink. This is FF00FF. This was 099. This was FF. So that's the main use of hex, is to represent very large numbers quickly. This can be, there can be many different representations. There can be a string. I love Java. It can be integers or numbers. It can be characters, ASCII and Unicode, and it can have colors like hex. Now, simple logic gates. There is a term over here, Boolean operators. Boolean operators are and or not, NAND, NOR, and XOR. This is basically what we are talking about right now, Boolean operators. So it's basically logical operators. What is logic then? It is how machine will solve the problem. Machines do not understand semantics like humans. No gray areas. It's either yes, no, or 0, 1, or true, false, stuff like that. So basically logic is how the machine will solve the problem. And how the machine, it will solve the problem through the help of Boolean operators, and or not, NAND, NOR, and XOR. These are some basic operators, but there are more complex ones also. But for the exam, the IB exam, you only need to know these basic ones. This is the basic gates, and, or, and not. And basically you have two inputs. When both inputs are positive, or in this case positive meaning 1, then only the output will be 1. Like we can see 0, 0 is 0, 1 over here, no, 1 over here, no. Both inputs A and B are positive, then only the output will be 1. So the AND gate is as its name says. Both inputs have to be positive. Input A and input B have to be positive for the output to be positive. That's for the AND gate. Two inputs have to be positive for the output to be positive. OR gate, one input, it's OR. One input has to be positive. 0, 0, no positive, so it's 0. 1 is in the input. As long as 1 is in the input, the output will be 1. So, and both inputs have to be correct or true for the output to be true. Or one input has to be true for the output to be true. A not, we basically flip the input. So if it's false, we make it true. If it's true, we make it false. So two inputs positive, then only output positive. One input positive, then output positive. Input is positive, output is negative. We flip the input. Now the next three gates. NAND or not AND. AND was two inputs are positive, then only one input is positive. NAND is the opposite of that. When both inputs are positive, the output is negative or 0. When one input is positive, it will be 1. When both inputs are also positive, both inputs as false, then also the output will be 1. As we can see here, both inputs are 0, the output is 0. One input output, one input is 1, output is 0. Only when both inputs are 1, the output is 0 for AND. For NAND, it's the opposite. When both inputs are 1, output is a 0. Sorry. When both inputs are a 1, the output is a 0. When there is one input at least, it is also a 1. When both are 0, it's still a 1. Because if it's, as we see, both are 0 over here. Both are 0, output is 1. So NAND basically take AND over here and completely flip it, kind of like NOT. So you put whatever the AND gate is for NAND, you flip it. As we can see, in AND, the last input is 1, the rest 3 inputs are 0. In NAND, it's opposite. The top 3 inputs are 0 and the last input, top 3 inputs are 1 and the last input is 0. So and NAND are completely the opposite. And both inputs have to be 1 for the output to be 1. NAND, if both inputs are 1, the output will be 0. Let's move on to the next one, which is NOR. That is not OR. In OR, we can see that only when one input is 1, the output is 1. 1 1 is 1. 1 over here is one output. 1 over here is one output. The only one where there is no output is when both inputs are 0. It's the opposite for not or. Only when both inputs are 0, output is 1. If one input is 1, output is 0. So again, NOR is a complete opposite of OR. As we can see, the bottom 3 inputs for OR is 1 and the top one is 0. For NOR, the top one is 0 and the top one is 1 and the bottom 3 are 0. So and when both are 1, the output will be 1, or when 1 is 1, the output will be 1. For NAND, it's the opposite of AND. If one input is 1, it will create a 1. If both inputs are 1, it will be a 0. If both inputs are 0, it will be a 1. For NOR, we can see if one input is 1, it's a 0. If both inputs are a 1, it's a 0. If both inputs are a 0, it is 1. And last one, XOR, exclusive OR. Over here we can see for OR, this is any input is 1, we get a output of 1. For NOT, if any input is 1, we get an output of 0. 0 0 will be a 1. For XOR or exclusive OR, only if one input is 1, we get a 1. Both inputs are 0, we get a 0. Both inputs are 1, we get a 0 again. If one input is 1, we get a 1. The easiest way to remember this, and if both inputs are 0, we get a 0. If both inputs are 1, then only we get a 1. For NAND, it's the opposite of AND. So for this, you can memorize AND truth table. This is called a truth table, by the way. The input-output relation is called a truth table. So if both inputs are 1, the output will be a 1. So for NAND, it will just be the opposite. So this will be 1 1 0. For NOR, it will be the opposite of OR. OR is 1 1 1. So for NOR, it will be 1 0 0. And for XOR or exclusive OR, only if one input is 1, the output will be a 1. Otherwise, it will be a 0. For NOT, it just flips the input and the output. So if the input is a 0, the output will be a 1. If the input is a 0, the output will also be a 1. Note, the IB uses their own symbols for logic gates, not the British standard ones. This is the British standard ones, which we would have used in the primary, not the primary, in the MYP. The IB uses this. So you just put a circle with the gate name, so or and. This is a possible real world applications for the all the gates which you studied right now. And for the fire alarm, smoke is positive, heat is positive, or either door open, either door is open, so it's giving a positive input. Microwave will stop if the door opens or vice versa. Security system is engaged up until both correct code and ID are scanned. Then it is disengaged. Air conditioning AC will only come on if both windows A and B are closed. Two lights switched on in one corridor. This is what is called a truth table, what we saw over here. Input, output, input, output, input, output. This is called a truth table. All possible combination. It is a mathematical table that shows all possible outcomes that could occur from the scenario. So true, false, input, output, 1, 0. Thank you.